rigid motions, so think of what a rigid motion means, and dilations. So think about rigid motion and dilations, what they might have in common. They both preserve what? Do the angle measures stay the same, or do the distance stay the same? Angle measures. So remember, dilations causes the distances or the side lengths to change side lengths. Number 2, fill in the blanks with one of the following words. Blank preserves distance. Is that rigid motion or dilation? So rigid motion. They don't give you enough room. Preserve distance, and then blank, do not preserve distance. Dilation is plural. Otherwise it wouldn't make any sense, right? So dilations do not preserve distance. So that's where that scale factor comes into play. Define similar polygons on the lines below. So Josie was complaining about the ancient review, right? But you had a review on similar figures. What is your definition of similar figures? But how? What's congruent? Angle measures, and then what do you know about side lengths? How are they different? Say that they're proportional, right? Didn't we just do a problem up there? So similar polygons corresponding angles are congruent while corresponding sides are proportional.
Is there like a sine proportion?
Nope. Darn it, right? Isn't that what a dilation is? Isn't that what we learned in the last section, was that corresponding angles are congruent. It maintains a rigid motion in the sense that it preserves angles, but side lengths from image to pre-image or pre-image to image are proportional. So that's really what you're going to explore a lot with today. So definition, 2 figures are similar if and only if there's a similarity transformation that maps one figure onto the other. So it has to be a similarity transformation. When a figure is transformed by a similarity transformation, it's a composition of a rigid motion and a dilation. So what transformations are rigid motions? Translations, reflections, rotations, and a glide reflection. So one of those mixed with a dilation will create a similarity transformation, in other words, a similar figure. Mostly because you've got that dilation in there. The first 4 that we talked about, the rigid motion transformations, those create congruent figures, but the minute you include that dilation in there, then you get that similar figure. So the image length of a dilation is 5 centimeters, and the corresponding pre-image length is 2 centimeters. Please circle the scale factor. So again, that's a review. So figure out which one's the scale factor. What is the scale factor? What over what? Image over pre-image. So which one did you circle? 5 over 2. Then number 5, the scale factor of a dilation is 2/3, and image length is 4 feet. Circle the corresponding pre-image length. Well, we're going to set up a proportion. So you're going to set up your proportion so that you have images to pre-image, and that's going to equal K, your scale factor. So we're going to use the same thing right here, but we're going to put in the information that we know. Well, we know that our scale factor is 2 to 3. And then it says the image length is 4 feet. Does that go in the numerator or the denominator? Excuse me, thank you. So image goes in the numerator, so our 4 feet is going to go up top. And then we're going to let x equal our pre-image. And so we've created a proportion. We're just going to cross multiply and solve. So if I cross multiply, I get 2 times x is 2x. 3 times 4 is 12 feet. And then divide by 2. And what does x equal? 6 feet. So therefore, our pre-image has a length of 6 feet. And that's what you're really going to be looking to do today, is setting up proportions for problems like those. So back to algebra. Yeah, we'll wait till you see the questions. And some of these I will gather, or I will admit, can be a little difficult. So let's just go through how they're walking you through this. So they give you a triangle, LMN, and they've given you the vertices right here. Suppose that the triangle is translated 4 units right and 2 units up, and then dilated by a scale factor of 0.5. Isn't that just 1/2 divided by 2? With center at the origin. It's important in the coordinate grid that our center is at the origin. For our purposes, we're not going to move it off of the origin. You're going to sketch the resulting image of the composition of transformations. So let's go ahead. We have to look at our translated figure first before we can apply the dilation. So if we go ahead and translate, so let's move 4 units right and 2 units up. And 4 units to the right means we're adding a 4 to the x value and adding a y, or 2 to the y value. So for m, we're going to go 4 to the right and 2 up, and same thing with n, and same thing with l. So plot those. So there's m prime. And there's n prime. And l prime. And of course, you're going to want to connect those with a straight edge. And I'm dotting the lines because it's not our final image. But if you actually record those ordered pairs, what do you get? What's l prime? What ordered pair? 0, 4. What's m prime? Excuse me. 1, -1. And n prime? 3, 3. So now from there, once you know your ordered pairs, it's easy to apply your scale factor. Since our scale factor is 0.5, don't we just divide each of these by 2? And don't let it bother you that we're plotting fractions. That's okay. So our L double prime is still 0, but it's 2. M double prime is 1/2, -1/2. N double prime is 3/2, 3/2. So L double prime is easy, and they went ahead and they plotted, by the way, for you here what we plotted above over here. So L double prime 0, 2 would be right here. And then M double prime, you're just going to go to the right 1/2 and then down 1/2. So you're right there in the middle, see if I can get it in there, of this box right here. So that's M double prime. And then N double prime, what's 3/2? What mixed number? 1.5. So you're going to go 1.5 to the right and 1.5 up. So you're in the middle of this box right here. N double prime. Connecting. There's your translated and dilated figure. So it gives you a similar figure. If we were to actually use the distance formula, which you are going to have to do that in your homework, use the distance formula to find the length from here to here. That length would be proportional to this length here of the original figure. But the angle measure here at L double prime is identical to that angle measure there at L. So it maintains angle measure, but side lengths are proportional. So that's not so bad, right? Problem 2 is a little bit more difficult. And I do kind of like the way they walk you through it a little bit. So as you look at this figure here versus this figure here, they say that what composition implies what? One transformation or more than one? A composition. More than one. So it's not just one that's creating it. And as you can see, this is obviously larger than this one. So they want to know what maps ABCD to MNHP. So which one's the image? Maps ABCD to MNHP. This is the image. So this right here is the pre-image. So what kind of dilation do we have? An enlargement or a reduction? We have a reduction, right? It got smaller. So we know that that's occurring, right? So we know that we have a dilation that's occurring. And then we had movements from here to here. So that movement occurred either with a translation or a reflection. I doubt it's a rotation because look, aren't these lines here parallel? I mean, it could be a 180-degree rotation. I suppose it could be that. So look at the fact that those are parallel. And at this right here, that angle right there, angle A, isn't that an obtuse angle? A really obtuse angle? What's the really obtuse angle in this figure here? M. And if you look at this, doesn't A correspond to M right here anyway, as they've written it? And so we're going to look at the actual ordered pair for the pre-image versus the ordered pair for the image. So if you would please record the ordered pairs for both of those, we're going to analyze them. So there's your ordered pairs. And then it's important to note, I want to look at A and I want to look at M. You want to choose one set of corresponding points and you want to analyze them. And that's what they're going to walk you through next. Point A corresponds with point M, right? And what does point D correspond with? D right here, what does it correspond with? Well, D right here is at the end, and so it must correspond with P. Use that to help you. So D corresponds to P. Then they want you to look at segment AD. Segment AD is located on the right or the left of the image, or the pre-image figure. The left side. And then segment MP is located on which side of the image figure? The right side. So those are corresponding sides. So for this side here to go from the left to the right, what may have happened? Most likely a reflection. It could be a rotation, but in this case I kind of doubt it, but it could be, still could be a rotation. But note that the rotation would have to be from A to the origin to M. Does that look like a 90-degree rotation to you? Maybe slightly over, I mean, it's slightly over 90, right? So I'm going to guess for right now that it's not a rotation. Just a guess. So I'm looking at a reflection and a dilation. So then let's flip to the next page. We might come back to this page, but let's flip. Okay, so they want us to look at where AD, how do we get AD to be parallel to MP? Because right now they're not parallel, right? So how are we going to get that? We already kind of said it, didn't we? Yeah, here's the problem. If we rotate it, won't A turn up being down here where P is? And won't D turn up being where M is? And are they corresponding to each other? No. So, but if I reflect it, won't A reflect over to where M is and won't D reflect to where P is? So reflection seems to be the smart way to go. So that's number 11. And then number 12 on the other page says, underline the correct choice to complete each sentence. Trapezoid ABCD is larger or smaller? Larger. And then to map, we need to enlarge or reduce or duplicate. What are we going to do from here to here? Enlarge or reduce or duplicate means the same size. It reduce, so circle reduce on number 12. And then by performing how do we reduce? A dilation, so circle dilation. And what's the scale factor? Look at from here to here. What do we do to go from -6 to 3? Divide by 2. Now I know that we don't have a negative, but why is there no negative there? Because I have a reflection, right? And then how do we go from -2 to... Am I looking at the corresponding sides?
Yeah.
But these ones are divided by 2 also.
Yeah.
All of them are, with the exception of... Oh, there we go. 2 divided by 2. 2 divided by 2 gives you 1. 2 divided by 2 gives you 1. This is the only one that's ugly. 1 divided by 2 is your 1/2. But they're all divided by 2 to get to these ones, correct? So scale factor divided by 2 is what? 0.5, 2, or 4? 2. So circle the 0.5. Did you say 2? We're dividing by 2. Circle the 0.5 because it's 1/2, right? If we're dividing by 2, your scale factor is going to be 1 over that 2. If we're dividing by 3, your scale factor is going to be 1 over 3. If we're multiplying by 3, your scale factor would be 3. If we're multiplying by 2, your scale factor would be 2. Does that make sense?
I think on H, aren't the points positive, 0.5 negative?
On H? Yes, I missed my negative. Thank you. All right, are we good? All right, so let's go to the next page. All right, so over here we should have the following: a reflection, circled, we've got larger, we've got a reduction, a dilation, and 0.5. So to map, we want to begin by reflecting. So that's going to be the first thing we do. It's much easier if we reflect first. So by reflecting ABCD across x equals, what do you think it's going to be? Look at your picture. What is halfway in between A and M? Find the distance from A to M. Well, that might not be fair. Let's try reflecting across the y-axis. Or maybe it's x equals. How far apart is A and M? They're 9 apart. What happens if we reflected A, though, over the the y-axis? What happens if we reflected it? We would be 1, 2, 3, 4, 5, 6 on the other side, right? So wouldn't we be at positive 6, 2? And then if you cut that in half, where would that put you? If we took A currently is at negative 6, 2. If you reflected it, so let's reflect it, across the y-axis, what would be the reflected point A prime? You do it. Turn your paper. It's going to be too hard for me to flip on my video here. So turn your paper. If you reflected A across the y-axis, what would be the ordered pair? Just reflect A. What would A prime be? What would be the new ordered pair? Across the y-axis.
6, 3,
It would be 6, 3, wouldn't it? Or no, 6, 2. It's the same height. 6, 2. Right? Because it's 6 away on the left, so you use 6 away on the right. Then apply your dilation of 1/2. So we would divide each of these by 2. What does that give you? 3, 1. And doesn't that give you M, which is 3, 1? Does that work? Does it work to reflect over the y-axis? Okay, so they're looking here for, this is the y-axis. The y-axis is x equals what number? 0. And you might want to put up here that that's the y-axis. So we're first going to reflect across the y-axis and then perform a what? Dilation. On A prime, B prime, C prime, D prime, which is exactly what we just did to this one point here. Using a scale factor of, I don't like to use 0.5, I like to think of it as 1/2. So that's going to be really hard for you to figure out. That's going to be your tough problems tonight. All right, so then let's look at problem 3 real quick. So this is using your knowledge of similar figures. So as we look at this, JK, notice that we've got what appears to be maybe a rotated figure and a dilated figure perhaps. But look at your numbers here, 10, 16, and 12. If I were you, I would order these from smallest to largest. So small, medium, large. And over here, order these from smallest to largest. Small, medium, large. And that's what they've done here. So JK is equal to what? 10. So let's put those numbers in there. And KL is equal to 12. And LJ is 16. So that's all one triangle. And if I were you, I would put here small, medium, large. And then on the other triangle, I would be ordering those identically. So RS is 12. ST is 16. And we'll finish this tomorrow. All right, so note that they ordered these, and I would be ordering them as well, from small, medium to large. And so over here we were in the process of ordering these from small, medium to large. And so the large TR was 20. And so this is your small size, your medium size, and your large size, because this figure has been rotated and or possibly reflected. Sometimes it's hard to tell. So if you order those sides in that way, then we can set up the sides and see if corresponding sides are proportional. And so question 15 says, underline the correct word to complete each sentence. Corresponding sides are proportional. And so that's what we were leading to. To determine if corresponding sides are proportional, what are we going to set up? Surely not a proof. We're going to set up a proportion, right? And so I want you to circle the correct proportion below. So look at these, and we've got to make sure that we do little triangle to big triangle, and or big triangle to little triangle. So JK is on the smaller triangle. So they're going small to large as far as triangles go. So I'm going to kind of put that out to the side. Small triangle to large. It's what they've done. Bless you. Maybe I'll put that a little closer to where it was. So we're just going to think small to large. So JK is the small side, right? On that triangle. So small. What's RS on the big triangle? Small. So they did small, so small. What's KL? Medium. And what's RT? RT is large. So is that a proper proportion? Yes or no? No. So we don't want that one. What about, okay, so we know that JK is small and we know that RS is small. What about ST? ST, but what's wrong with ST and JK? JK is on what triangle? The small triangle, this one. So shouldn't ST be from this one over here? So if we started with a smaller triangle here, aside from the smaller triangle needs to be here. And that's not what ST is. ST is from the bigger triangle. We can't go small triangle to large triangle and then go from large triangle to, actually they did large triangle to large triangle, didn't they? So both of these are from the same triangle, aren't they? And both of these are from different triangles. So that's why that's not a proper proportion. So my hope is that the last one is the proper proportion. And is this going to be the only proportion we could set up? No. This is just an example. So JK again is small, RS is small. What's KL? What's KL? KL, what is KL? Medium. KL's on a medium measure. And it's on the smaller triangle. So we did small triangle to large, small triangle to large triangle. So this is from that small triangle. I know we're using a lot of smalls and larges, but I think you get the idea. And then ST is what? Medium. Is that a proper proportion? Yes. So then we're going to fill in those values below. So JK is 10. Actually, I think I'll use the same color as I have up there. So JK is 10. And RS is 12. KL is 12. And ST is 16. So what number goes into both 10 and 12? 2. And so 2 goes into 10 5 times, and 2 goes into 12 6 times. What number goes into both 12 and 16? 4. 4 goes into 12 3 times, and 4 goes into 16 4 times. Are those equal? They are not equal. So what does that, so they are not proportional. So what does that tell you about the triangles? They are not similar. So there is not a similar transpiration that will map that one triangle onto the other. So don't assume that the sides are going to be proportional. You have to make that determination yourself. And so since the sides are not proportional, this was not a proper dilation, because a dilation will give you similar figures. All right, so last page. You do the lesson check. So find the vertices of TUV. So I put up here the vertices of the preimage TUV, and they asked you what happens when something is reflected across a line, and your answer should be, because that's a rigid motion, your answer should be that corresponding angles and sides are preserved. In other words, corresponding angles and sides they remain congruent. And so then I wrote in number 21 what the resulting ordered pairs are for the reflection across the y-axis. And then next they're preparing you for the dilation. So the dilation, corresponding angles remain the same, congruent, but corresponding sides are proportional. So you do want to maintain that thought. And so we're going to dilate, I don't want to lose my picture, we're going to dilate with a scale factor of 0.5, which means we're doing what? Bless you. Dividing every x and y by 2. So we're going to divide each of the x and y's here, each of these here by 2. So I'm going to go ahead and put, well, I don't want to muck that up. So 5 divided by 2 gives you 5 halves. 4 divided by 2 is 2. And then for u prime, 3 divided by 2 is 3 halves. And negative 1 divided by 2 is negative 1 half. For v prime, 1 divided by 2 is 1 half, and 3 divided by 2 is 3 halves. So we're going to go ahead and plot that above. So we get 5 halves is 2.5, so 2.5, 2. Puts us right here for t double prime. And then 3 halves is 1.5, so to the right 1.5, down a half, puts us right in the middle of that grid box there, and that's your u double prime. And then v is to the right a half, up 1.5, so to the right a half, up 1.5, puts us right in the center of that box there, which is v double prime. So if you connect those with a straight edge, of course, there is your reflection and dilation, your final figure.